Hello, everybody. Welcome back this week to Calculus. This is going to be about the last week of content that we will do. And after we get back from our little e-learning break next week, I'd like to kind of do a few senior traditions with you that I normally do with my calculus class. Like the senior textbook project. So you can choose a section and make a little textbook on it. And then the senior project that we had those days that you signed up for, I do want to still have you all present that. A lot of you, have been working on those presentations and the lit review. So I'm going to give you, about a week or so to work on that project, send me, those final drafts, and I even would like you to experiment with maybe making a YouTube video or using the voiceover feature on a PowerPoint. That way I can share everybody's presentations on the Haiku page, and everybody can even comment, and you can hear each other's voices for the last time. So, anyways, what we are going to do today is pretty much the same idea of finding area between the two curves, but we can see sometimes that there's actually going to be some situations where maybe instead of drawing vertical rectangles, so I'll kind of demonstrate what we did last time. So this is with respect to X approach, drawing those up and down rectangles, where we're taking the integral of top minus bottom, and I'm being a little crude here, but this is the main idea here, integral of top minus bottom. Sometimes it's of an advantage to do the integral instead in a right-left direction. So the way that we interpret that geometrically, let's say that I got two curves, and I'm just making them up here. We will call, for instance, the f of y, and then the g of y will be, what's kind of on the left. And instead of drawing rectangles that are up and down, we're going to draw kind of infinite amount eventually. But we're just kind of adding these rectangles now that kind of have a right-left style instead. And we use this situation when we get that x equals form. So the rough formula on some of these problems today is you're going to take the area between A and B, where A and B now are y values. So B is the higher y value and A is the lower y value of right minus left dy, or what the actual formula would be, is the integral from A to B of f of y minus g of y dy. I'll just put a little box around there. And that's the general formula that you are going to be using. So number one would be something that's really set up well for that right-left integration. So this is example one. And it's set up for right-left integration because you have x equals. So we can kind of see that this y squared thing is the right, because it's kind of like that parabola on its side. And then the x equals y plus 1, well, that's kind of linear. So that's the left. So as long as you know your right and your left, when I'm doing this type of problem, I would even just do, it's a little crude, but I kind of like it because it gives us the concept of this problem. So I'm taking the integral of right minus left, and it's with respect to y this time. So it would be the integral of 3 minus y squared minus y plus 1 dy. And I like to combine like terms, get it into a polynomial. We can kind of see the y values of these intersections on the graph. So we have our -2 to 1. So that's our limits of integration. And I'm just going to do the same integral of -2 to 1 of negative y squared minus y. And then I have a 3 minus 1, which is a plus 2. And this is pretty much like your regular integral, except now we just have y's instead of x's. So we're just kind of going in that left-right direction. So that's why, we have the y's here. And it does tell us to just set up the integral to find the area. So we'll just save a little time with that. What we're kind of aiming at here is just the concept of this. Now, let's say that we had a little trouble seeing the y value and we wanted to find those intersections. So I'm just going to show you why the limits of integration are -2 to 1. So I would have 3 minus y squared equals to y plus 1. And I like to get that positive y squared. So I'm going to move the y squared to the other side. So that would be y squared equal plus y. And then I have 1 minus 3. So I'm moving the 3 over to the other side. So it will be a -2 equals 0. And if we factor, we get y plus 2 times y minus 1, which effectively gives us y equals to -2 and y equals to 1. Now, if it's pretty obvious from the graph, you don't have to map out these intersections, but if you're having a little trouble seeing it or you just want to convince yourself, I think this exercise of finding the intersections is going to be really good for you. So if it is in terms of y, so you have an x equals equation instead of a y equals equation, that tells us that we have a right-left integral. So we're always going to have this format of integral of right minus left. So please stay tuned for some other examples in future videos. There are actually some situations where we could actually weigh in whether we want to do right minus left or top minus bottom. So that's what we're going to see in the next video. Thank you very much, and see you soon.